Assalamualaikum and hi again. We have been introduced in the introduction to Fourier series that the Fourier series expansion can be categorized or can be defined in two means. One using trigonometric form, another one using complex form. So now I will talk about the Fourier series expansion using trigonometric form with general Fourier series formula. Okay? Alright. We know that the Fourier series expansion can only be done using a periodic function. Okay, so as you can see here, Fourier series expansion of ft equals to ft plus capital T here actually represent a definition of periodic function where for any ft will be equal to ft plus period here. And we will consider two cases. First, when the period not equal to 2 pi, and the second case is when the period equals to 2 pi. Okay, so for this particular case, okay, we can consider that t or the period here equals to 2 pi per omega. Okay, and then the omega can be defined as 2 pi over t. Okay, so why do we need this information of omega? Because as we knew before this, in order for us to do the Fourier series expansion, we should know the terms of the Fourier series expansion. Okay, so in order to find the terms, here is the formula. Okay, so this equation shows a formula of Fourier series expansion using trigonometric form when the t not equal to 2 pi. Okay, so you can see first, the first term is half a naught. Okay, when the a naught is actually the coefficient, okay, of this Fourier series expansion, and the second terms are the summation of an cos n omega t. Okay, and you can see here that the n starts from 1 to infinite, so we can say that this is actually another summations. Okay, another summation of all the an cos n omega t, and the second or the next terms are consisting by using this definition, which is the summation of bn sine n omega t, and the n starts from 1 until infinite. So the question is, how can we find the a naught, an, and the bn so that we can represent this ft with the Fourier series expansion? Okay, it is given from these two equations. So the first is an, given by this equation, where we need to identify what is the period, what is the omega, and another one is what is the boundary of this integral. Okay, so the same also goes to the bn, where we need to also know about the period, the boundary of this integral, and also the omega. Okay, so if the n equals to 0 in this case, okay, we can now simplify it like this. When n equals to 0, okay, we can use the same formula here. N equals to 0, we have 2 over t multiply with the integral of ft multiply with cos 0. So cos 0 is 1, and then there is no need that we need to multiply with this value, so we only have ft dt. Okay, so this is how we can find the a naught. Okay, but for the rest, we need to use this formula. Okay, now if we consider another case where the function of this periodic function has a period of t equals to 2 pi, okay, then we can take note that when the omega equals to 2 pi over t. Okay, and when the t equals to 2 pi, we have 2 pi over 2 pi, result to omega equals to 1. So the formula in equation 1 here can be now simplified with omega equals to 1, so it becomes like this. Okay, so what you can see here is a general formula for a Fourier series expansion using trigonometric form for a periodic function where the t equals to 2 pi. Alright, so using the same formula as in equation 1, okay, when we know that the t is exactly 2 pi, then we will get this formula of an and this bn. Alright, so the same question, okay, also arise here, where we need to know what are the a0, an, and the bn using these particular equations. Okay, so for any Fourier series expansion, okay, these coefficients are very crucial for us to identify the ft. Okay, so there is a simple tips here. If we have a periodic function where the t not equals to 2 pi, then we can use equations in series 1, okay, like this one. Or if we have t equals to 2 pi here, we can straight away use this series. Alright, now let's go to the example. If we have a periodic function like this, okay, so let's see to the question. A periodic function ft of period 4, that is ft plus 4 equals to ft, is defined in the range of t from -2 to 2 by this equation of ft. Ft equals to 0 when the t starts from -2 to 0, and the ft defined as 1 when the t starts from 0 to 2. Okay, the question: sketch a graph of this ft for this domain, starts from -6 to 6, and obtain a Fourier series expansion for the function. So now, when we like to sketch a graph, we need to have an understanding of a function. If we can see from this equation, this is a piecewise equation function where this function can be classified into two functions, okay, two separate functions. First, the ft only defined as 0 for this domain, and the ft equals to 1 for this domain. So if we like to sketch the function, we can start with this domain first. So we start from t equals to -2 here, okay, until 0. Okay, so we are considering this one now. So for this domain, what is the ft? The ft is 0, so you can sketch like this. Okay, and for the second piece equation is ft equals to 1 for this domain. So looking at this domain, it is referring to the 0 to 2. So by identifying this domain, then we can know that the ft equals to 1. So we sketch this graph as 1 throughout the domain. Okay, so looking at this equation, okay, we can only draw this region only. But since we know that this ft plus 4 equals to ft, meaning that this function is periodic, we can repeat the same pattern of this basic function to the rest of the graph. So since this is the basic, we can now start from here and then here, and we will repeat again the first and the second. Okay, repeat again, and also like this one, we also can repeat the first like this and the second like this with the similar scale. I mean, if you have -2 to 0 here with 2, and this one 2 as well, so this scale should be 2 as well for all the particular cases. Okay, and in this case we can also see that the t always follow to the value of 4. Alright, so this is how we sketch the function. Alright, now if we know that the t does not equals to 2 pi, then we should know about the relationship between omega and 2 pi, omega and the t. So the relationship is omega equals to 2 pi over t here. So knowing this, we can go to the next one here on how can we solve the Fourier series expansion. At the moment, I would like you to really understand what are the steps, or how can you identify the values or the important values, okay, so that you can solve the Fourier series expansion. So I list down all these steps so that you can follow by first identifying the period, okay, based on the question. So based on this question, okay, we can see that the period is clearly said as 4. Alright, so we know that now the t equals to 4, so omega is given by the equation of 2 pi over t, which result to pi over 2. After that, since we know that the period here is not equals to 2 pi, then we can use series 1 to find the Fourier series expansion and their coefficients. So not only that, we only need to identify what is the ft and the boundary for each ft. In this question, okay, since we are given a function, a piecewise function, which contains of two separate function, okay, then we need to identify the boundary for each. Alright, so first of all, we have ft equals to 0 when the boundary starts from -2 to 0. Okay, and the second function is ft equals to 1 where the boundary starts from 0 to 2. Okay, so it means we need to consider these both functions. So when we consider the ft in this case, okay, for the a naught, recall that a naught equals to 2 over 2 over t multiply with the summation, multiply with the integral of ft dt. Okay, so we need to know what is the ft. So now we start from the boundary from -2 to 0 first. We cannot straight away start from -2 until 2. Why? Because throughout the t from -2 to 2, it does not share the same function. Okay, remember, based on the question. So we need to split it. Okay, so when we identify the boundary, we need to know which function and which boundary. So for the first function is when ft equals to 0 from -2 to 0. So we got this. And the second one is when ft equals to 1 and the boundary is from 0 to 2. From here, then we solve the integral and get the a naught. Okay, and the same for the an here. Okay, for the an, okay, in general, okay, we will get this equation, okay, where we need to identify the boundary and ft multiply with the cos omega and omega t. Okay, so now from this, from here, okay, I just like to take your attention that cos and omega t now becomes cos, and the omega is pi over 2 t. Alright, so we get now cos half n pi t. Alright, and by using the integral, we will get the an. Okay, next for the bn is also the same thing, but we multiply the ft with